Okay, you might have seen another formula for that, and to derive that we have two options. The first one is very simple, and it is a little bit of trick there, and it is just like before. D or lambda is equal to lambda prime plus, if it is coming toward me, plus lambda or d of s. Let us write it in distance form. D is equal to d prime plus d of s, and we know distance is equal to velocity. D is equal to velocity times time. So we have traveled two wavelengths with the speed of light, and in time, two time periods. That would be equal to, again, the distance traveled by the speed of light. Or first let me bring this here. D prime is equal to D minus d of s. Now d prime is traveled in a distance. Let's have it as d prime is equal to the velocity of light multiplied by time, which is our period, minus the velocity of particle multiplied by exactly the period. Now this d prime is also, it is either bigger than lambda or smaller, so let us call it lambda hat, and lambda hat is also the velocity of light in a period which is actually shorter. It goes 8 meters in two period, but reaches the place of the second wave in shorter period. So let us call it t hat. So v time t hat is equal to velocity of light time minus velocity of particle multiplied by time. Now here is the trick. I know the period didn't change from these two, but I know this period has definitely been changed, been shortened. But I can say I have reached the place in a shorter time, but I didn't do actually anything. If I let the time period be the same and change my velocity, it didn't actually happen, but let's consider it a trick. So it is v prime time the same t is equal to vt minus vp multiplied by t. So I have t here, I can cancel it. So just write it down for myself. T is not actually the same, but I can borrow from time and add or increase or subtract my velocity. So that was the trick we did. Now again, velocity is what? Velocity is actually lambda times frequency. Lambda and frequency they do not need to be always following the rule that if you increase the lambda you decrease the frequency. These two are two different things. So I can change my lambda or my frequency and let the lambda be the same. Therefore, lambda multiplied by frequency is again lambda multiplied by frequency minus the velocity of the object. And from this I can bring these back and write lambda f minus lambda f hat is equal to the velocity of my particle. If I factor the lambda out, it would be f minus f hat is equal to velocity of my particle, and therefore my delta f is equal to velocity of particle over my lambda. Again, velocity is equal to frequency times lambda. I can say my lambda is equal to velocity over frequency, or write it as this: my delta f is equal to Vp over velocity multiplied by frequency. Now we just need to consider one thing, and that is, as I'm sending my wave toward the particle and it travels back, it is actually two times of going up and going down. So I would need not to consider it as well and write it to here, going up and down. Now there's a second way. It is a mathematical way, and I prefer it because it is more understandable and there is no trick, and that is as follow. We need to define phase shift. Phase shift, and the formula is as this: phase shift is equal to 2 times d multiplied by 2 pi divided by lambda. If the particle that I'm aiming at has a speed toward or away from the observer or receiver, it's a speed. It is going toward me, it has a speed. It is going away from me, it has a speed, and that speed can be defined by time, which would be it is the radial speed, and that would be the frequency shift, phase shift of that over time. Let us call it radial, or VR, which is velocity of radial. It would be 2 times d multiplied by 2 times p over lambda,